Lesson 19.4, Task 3. Use the sampling distribution of the sample mean. What is the probability that a random sample of 20 of the cereal boxes in Task 2 has a mean of at most 12.35 ounces? Find the mean of the sampling distribution of the sample mean and the standard error of the mean. All right, so we know that the mean is 12.3 and the standard deviation is going to be standard deviation divided by square root of n. All right, so in this case, n, the sample size is 20. So we're going to do 0.15 divided by the square root of 20 is going to be approximately 0.03354. All right, so it says, how has the standard error of the mean changed from the one you found in the previous task? The previous task had a standard deviation of 0.03 and it had a sample size of 25. So this one is 0.03354. So this one is slightly greater because the sample size is slightly smaller. All right, so this standard error is going to be a little bit greater because the sample size is a little bit smaller. So that's what that question is basically saying. All right, so it says use a graphing calculator or other technology to find the probability of x's, this is your mean, when it's less than or equal to 12.35. All right, and it says that this is approximately 0.932. How do you know that the sampling distribution is normal? There are less than 100 cereal boxes. The weights of the cereal boxes are normally distributed. There are more than 10 cereal boxes. The weights of the cereal boxes are normally distributed. Okay, so I don't know if I said this one right. This one says they are not normally distributed. This one says they are. All right, so we know that this does fit a normal distribution curve. So this would be normally distributed because it fits in the 68, the 95, and the 99.7% curve. All right, so it says the probability that a random sample of 20 boxes has a mean of at most 12.35 ounces is about 93.2%. Lesson 19.4, Task 4. Use the sampling distribution of the sample proportion. For a sampling distribution of the sample proportion P represents the proportion of individuals in the population that have a particular characteristic. That is the proportion of success. The P, and it has kind of like a little hat on it if you can see it here, is the proportion of success in the sample. The mean of the sampling distribution of the sample proportion is written as the mean subscript P here. The standard deviation of the sampling distribution of the sample proportion is written as standard deviation of P, and it's also called the standard error of proportion. All right, properties of sampling distribution of the sample proportion. If a random sample of size n is selected from a population with proportion P of successes, then here the mean sub P equals the P, and the standard deviation of P equals the square root of P times 1 minus P. Remember, P is your successes, and so 1 minus P would be like Q from a previous lesson, but P plus 1 minus P should equal 100%, and then that's divided by N, or your sample size. If both NP and N times 1 minus P are at least 10, then the sampling distribution of the sample proportion is approximately normal. All right, so this is kind of important. So if NP and N times 1 minus P are at least 10, so greater than or equal to 10, then the proportion is approximately normal. All right, so they're giving us that 35% of all residents commute more than 45 minutes to work each day. All right, so that's going to be considered our successes. So it says a recent census of a major city asked how long people's commutes were. When sampling from this population, consider successes to be people who commute more than 45 minutes to work each day. For random samples of 40 people, what interval centered on the mean of the sampling distribution captures 95% of the sample proportion? So if you remember, 68 is 1 standard deviation, 95 is 2 standard deviations, and 99.7 is 3 standard deviations. So in this case, 95 should be 2 standard deviations. All right, so it says identify N and P. So N, if we look up here, it says sample of 40 people, and P is 0.35. So 35% can be written as 0.35. That's considered our success. All right, so it says what does 0.35 represent? All right, it represents the probability of success, which in this situation is the number of people who commute more than 45 minutes to work each day. Find the mean of a sampling distribution of the sample proportion and the standard error of the proportion. All right, so that's given using the formula given above. So if you go back up here and look, we're going to do the square root of P, that's our successes, times 1 minus P, so that's 1 minus whatever this is, that's going to give us that difference, divided by N, and in this case, N is 40. All right, so our successes was 35%. 1 minus 35% is the 65%. So we're going to multiply those, divide it by 40, and take the square root of that whole thing. That's going to give us about 0.0754 or 7.54%. All right, so it says since NP, all right, N again is 40 and P is 0.35. So if that NP equals 14 when you multiply, and N times 1 minus P, or the 0.65 equals 26, those are both greater than 10, and sampling distributions of a sample proportion is approximately normal. So again, 14 and 10 or 26 are both greater than 10. And go back up here and it says that that means they are approximately normal. All right, so then it shows you here that if we do the mean minus 2 standard deviations, okay, the mean is 0.35 minus twice this here, the standard deviation, then we're going to get the lower end of our curve. And then if we have the mean plus 2 standard deviations, that's going to be about 0.35 plus 2 times the standard deviation here. And that's going to give us about 0.5008. So it says within how many standard deviations of the mean does 95% of the normal distribution lie? Within 2 standard deviations. So 95% of the sampling proportions fall within 19.92% and 50.08%. All right, that's all for task 4. If you have any questions, let me know. Lesson 19.4, task 5. Use the sampling distribution of the sample proportion. What is the probability that a random sample of 50 people from the census have a sample proportion of at most 27%? Successes are defined the same way as in task 4. All right, so it says identify N and P. N is 50, okay, that's the sample size, and P is the probability of success, so that was 35% from the last task. All right, so it says how does the probability of success affect the standard error of the proportion? So the closer the probability of the success is to 50, the greater the standard error of the proportion will be. All right, so it says the numerator of the square root of P times 1 minus P over N is largest when the probability of success is around 50%. All right, so find your average. Okay, so when it's 35%, we know that this is going to be approximately 0.067. Okay, and that's using the formula from above. And then it says since both NP and N times 1 minus P are greater than 10, we know that this is approximately normal. So then it says use a graphing calculator or other technology to find P for x less than or equal to 0.27. And that's going to be approximately 11.8%. All right, if you have any questions on task 5, please let me know.